so now we're going to take that idea of LCM and use it to help us solve some equations. The first one that I see, I have fractions, so these are an example of rational equations. When you have a single fraction is equal to a single fraction, we can actually just cross multiply. This is a proportion, so we can cross multiply and make this x times 5 equals 3 times 4. And then that's a linear equation that we can solve. So anytime that it's just a single ratio equal to a single ratio, we have a proportion, and then we can solve by cross multiplying. So we're just going to make this 5x equals 12, so we're going to simplify both sides, and then just solve by dividing by 5 on both sides. So we get x equals 12 divided by 5, which is 2.4. So that would be our answer. We could also look at this using the LCM. So I'm going to show you this problem in two different ways because I do think that it's important to understand the connection between the LCM. When you have a rational function, what you can do is multiply both sides by the least common multiple, and then if that will divide both of those denominators. So we're looking at the 3 and the 5. The LCM of 3 and 5 is 15. So what I'm going to do is I'm going to take this equation and I'm going to multiply both sides by 15. Now remember, 15, when I'm dealing with fractions, I can just look at that as 15 over 1. And then I can multiply straight across. And you'll see what happens here when I multiply that LCM. Because again, the LCM is the least common multiple, meaning that it divides both of these. So if I write this, simplify it, I'm going to get 15 times x over 3 equals 4 times 15 is 60, divided by 5 times 1 is 5. So again, just multiply straight across. Then you might be thinking, well, you still have fractions, but these fractions reduce. 15 divided by 3 is 5, and 60 divided by 5 is 12. So there we go. We ended up at the same place that we did over here, and now I divide by 5, and I get x equals 2.4. So anytime that you have fractions, and I know a lot of people don't like fractions, they seem to kind of scare people off a little bit, but you can kind of just get rid of them. Like if you're solving an equation with fractions, you can get rid of them out the gate by just multiplying through by the LCM like this. So it's a very useful thing to use in math and solving. Here's another example. What we're going to do in this one is I'm just going to use this method where we solve by multiplying by the LCM. 5 is not a fraction, so the denominator is understood to be 1, so I'm really only concerned about this. And when there's only one denominator, then that must be the LCM. That is the LCM. So I'm going to multiply both sides by that LCM. By the way, before I do this, notice that there's a negative out here. It's a negative of the fraction, which is the same as having that negative attributed to the numerator. So I'm just going to treat that as a -3 so that I don't have to worry about that negative with this denominator. That is equivalent to what we started with. So what I'm going to do is I'm going to multiply by m plus 4 on both sides. So over here I'm just going to have to distribute. Notice over here, again, when you multiply, it's understood to be over 1. So this is, I'm going to start on the left and I'll come back to here, but we're going to distribute this. So we get 5m plus 5 times 4 is 20. And then over here, what I would end up with is -3 times m plus 4 over m plus 4, and you could maybe see this in the previous step, but those just cancel out, so you're really just left with -3 there. And then this will be 5m plus 20 equals -3. And then it's just a matter of solving from there. So we're going to subtract the 20 on both sides and just solving the linear equation, and we're left with 5m equals -23. And dividing by 5 on both sides, we will get m equals -23 over 5. You could leave that as an improper fraction, or as a decimal, that will be -4.6. And that is your answer. So that's how we solve rational expressions. Just multiply both sides by that LCM to get rid of the fractions altogether. So even if you had more going on over here, if you had plus another fraction, you could find the LCM and multiply it through by every term on both sides. And it would end up canceling out those denominators so that you end up with a linear equation that you can solve pretty easily. All right, so that's it for LCM and solving rational expressions.